We can derive any get from the matter now. So there are OR get, AND get, NOT get. Now everything can be implemented using Verilog. Yeah. Second one? Yeah. Please. So every design. Please be muted. Online students, please be muted. Now, every design can be.
Hello, sir.
Yes, please tell me.
Sir, where is the offline classroom, sir?
Now, third floor, tier 1.
Third floor, TR1.
Tier 1.
Okay, sir. Okay, sir. Thank you, sir.
So every design can be implemented using Verilog. Anything. You tell me, implement an AND gate. I can implement an AND gate using Verilog. Okay. You tell me, please implement a half adder. I can do that. Any kind of mux. Okay. Any kind of mux, we can implement. Okay. Now, then the question comes: why we need Verilog? Why not C programming? Why not any software program to be used to implement these designs? Question is, why Verilog? Why not? Okay. Verilog is hardware descriptive language. What do you mean by this hardware descriptive language? We can implement whatever logic we are going to write. Okay, we can implement that in real-time chip. Okay, but for C programming, we can't do that. C programming or any software-based language, what they do, whatever is been done, all those things are virtual. They do not have any physical significance. Yes or no? If I develop a software or if I develop an application, okay, using some software language, that application is there in the mobile, but it do not have any physical significance. Right? If you tell Flipkart is an application. You can see Flipkart, but can you hold Flipkart? That application can you hold? Means that is non-tangible. But using Verilog, whatever we are going to write, the design, we can convert them into real-time chip. Everything can be converted into gate level. Gates. If I write, suppose I'll create a file. Sample.v. This .v means the extension is Verilog. .txt is text document. See, if you can see my screen, this is .txt file, right? So this is nothing but a .txt file. If I save this one, whatever I am going to write here, that will be converted to a notepad file. Whatever I am going to write here, .v, that is a Verilog extension file. So it will show you different symbol. In suppose I'll write module in the module. Simple. Save this one. Save. Okay. And I quit. I quit. Now you can see the difference in the folder. In this directory, I have started from this one. I created one notepad file, new text document. I opened that using GVI. If I open this one, it will open in GVI because I have made that as default as GVI. Okay. But you can see the difference in between them. This symbol is different. This symbol is different. Yes or no? This symbol signifies Verilog file or system Verilog file, whatever. So if I open this one, this is Verilog file. If I want to open the text document, but I'll need to simple. What are the shortcuts I am using? Are you able to understand? I am using VSPL. VSPL will split this screen vertically. You can use SPL also. SPL will split the screen horizontally. Whatever you think that it is easier according to you, you use that one. There is nothing that I am using VSPL means you also need to use VSPL. You can use SPL. Okay. There is another shortcut that is called tab new. Tab new will do what? It will open a file, sample 1.b, in a new tab. Enter tab. It has been opened. Previous one was here in this tab. So anything, whatever you think that easier for you or convenient for you, you can use it. Okay. Now you can see another difference is if I write module here in the module here, is there any changes? Color change is happening. What is the reason behind that? Because of the syntax. Because of the syntax. .v file understand the syntax. .txt do not understand the syntax. This represents a keyword with respect to Verilog, but this is not a keyword with respect to .txt. Okay. Next one is model C. Model C structure. Run the simulation. Model C is an open source software. You can install it by free. Okay. So after the session, I will show you how to run a code in Model C today in today's session. Then I will ask our administrator to share the link in the group. Okay. You have to. It is already shared now. So everyone has installed. Everyone, anyone here do not install. So you have tomorrow, right? Okay. Please install that one. Okay. Because whatever simulation we are going to run in Model C, and you have to learn a tool. You have to learn a tool because when you enter in the industry, you are going to work using tool. They are tool only. It is not like that they are going to use Model C only. Model C is very basic. Okay, basic one for verification. Going forward in system Verilog, we are going to use QuestaSim. Okay, QuestaSim is industry standard tool which will be used in the industry. Most of the company for verification they use QuestaSim. Okay. Next, how to run a simulation using models. That we are going to start today. Okay. Now, whatever I am going to write here, I will explain. If you are not able to understand or not able to remember, there is no problem. Because the same thing we are going to explain again. But what I need to do here, I need to implement a design. Okay. Now, coming to another point, if I write a design, is it sufficient to understand whether the design is correct or not? I implement the AND gate. Suppose I implement the AND gate using Verilog. Now, how I am going to understand or how I am get to know that this AND gate is working fine? Debugging. Before debugging, what is needed? Test bench is needed. You are going to debug the test bench, right? Means debugging is always there. But on what point you are going to debug? You implement the design. Okay. How you are going to run the simulation or run the design in the tool? For that you need test bench. Because in design what we write? See, what is a, just understand this one. What is the truth table of AND gate or what is the logic of AND gate? If any input is low, the output will be low. If both the inputs are high, the output will be high. That is the logic of AND gate, correct? Yes or no? You can see the truth table 0 0 is 0 0, 1 is 0 0, 1 0 is 0, 1 1 is 1. So from that one we can write two lines. Because in interview also, if someone asks you, please tell me the logic of AND gate. Please tell me the logic of AND gate. You have to tell this two lines. If any of the input is low, the output will be low. You can, instead of low, you can tell 0. Okay. You can tell false. There is no problem. If both the inputs are high, the output will be high. This two lines you have to. Nothing else. Nothing else. You draw and get, no, not needed. I am giving sir 0 0. I am getting 0. This is one logic. No. This two line is right. Okay. So whatever the logic is there for AND gate, the same thing we are going to write here. We are going to write here. Nothing else. Now we know the logic. We know the truth table, everything. But when we are using some language, how that language will understand that, okay, 0 0 is coming, so I need to give the output as 0. How the language will understand? For that there are two aspects. There will be two parts. One part is design, that you already know, the design part. Design part means I am not telling that you know how to write the language. You know the logic of the design. Next part will be test bench. In test bench, what we are going to do? Any idea? We are going to generate inputs. So, let me write this one. Verilog. There are Verilog with respect to one, a design file should be there. It's the bench file. Here. We connect our test bench with the design. Then we run the simulation with respect to test bench. Then if we get any error, then we are going to debug it. So for debugging, we need test bench. Next one is when we are going to run. Okay, we don't run the design. We include or we connect the design with the test bench. We run test bench in the system or in the tool. Now tool will do what? tool will understand the test bench, whatever I have written in the test bench. According to that, it will generate the inputs and it will give you the output. From there, you are going to understand whether whatever the AND gate you have implemented, whether it is correct or not. Okay. So, next one, simple. I am going to implement the basic AND gate. Okay. Another thing I want to tell you, whenever you are going to give any name to any file, okay, do not use space. One thing. Suppose I have written AND gate, correct? So you can think you are going to give a space in between AND gate and space gate. Don't do that. That is wrong. Whenever you need to give any space, use underscore. See, underscore also give you the difference, correct? A space. But it is a special character. So whenever you are going to give any file name, okay, there should be no gap. And that also applies for the folder name. Whatever, when you are going to work with Verilog, okay. Now going forward, what you need to do, you are going to create some design test benches, okay. For that you need to create some folders. So for folder also, whenever you are going to give any name, do not use space. Okay. You can see I have given AND underscore gate. Okay. Next, in Verilog, whatever we are going to write, we write inside module, end module. Okay. Whatever, anything that we are going to implement, that should be written inside module and end module. Next. Then when I am writing module, there should be a module name. After writing module, there should be a module name. What will be the module name? It's good to keep your file name and module name same. I am not telling you that it is a rule. I am not telling you this is a rule. It is a good practice to keep your module name and your file name the same. I'll tell you why it is useful. It will help you to decrease your chances of getting error. Okay. Then open braces, close braces. Inside that, what we need to give inputs and outputs. Okay. I'll give A comma B comma. Instead of Y, you can write out. Instead of Y, you can write your name. Instead of A, also you can write your friend's name. B, your friend's name. But this name doesn't matter. Okay. But there should be some significance for this name. That input A, input B, input Y, output Y. Now the question comes, so should I write always inputs then outputs in the port list? No. You can write Y, B, comma A, Y, comma B, comma A. There is no problem. But that also we are going to see that whenever you are going to write the same, you also need to write the same in the test bench. That we'll see. Okay. So the first line. What you need to do here, module, then module name. Inside that, we call this as port list. Port list, which is nothing but inputs and outputs. Okay. And semicolon is. Okay. give semicolon whenever we need to end any sentence or end any statement. Instead of sentence, you can mention statement. Okay. Next. Input A, comma B. Output. Okay. Next, what you need to do? Declare the variables. Here I have three variables, correct? A, B, and Y. A and B is our A and B are our input variable. Y is our output variable. Right? Input A, comma B, output Y. Now question comes: can I write input A and input B? Instead of this, if I write input, will there be any problem? But instead of writing two lines, you can write inside one line. Okay, that's why input. What is the size of this A and B? Can anyone tell? What is the size of A and B? One bit or two bit? Huh? My question is, what is the size of A and B? 1 bit. By 2 bit.
1 bit.
A is of 1 bit. B also have 1 bit. A and B are. It is not like that A and B combined. A and B combined, they are 2 bits. Okay. But A individually it is 1 bit. B individually it is 1 bit. Y also individually 1 bit. So next step will be declare the output variables. Okay. What will be the next part? Next one will be logic. Logic can be of 3 types. In Verilog, we can write the logic in 3 ways. No, actually 4 ways. One way we don't use. Okay. We mostly use 3 ways. What are the different ways? Behavioral, data flow, and etc. Okay. There is some difference between structural and get level. Okay. So for now, you just understand get level. So these are the 3 styles. Using any style, we can implement the design and the output will be same. Here I am going to use behavior. Okay. Now for behavioral, we use always block. Always at the rate. We say posit. Don't say posit. Please tell me who said, then I can explain that why we are not going to write posit here or where we are going to write posit. You don't know. No. No. Where posit is needed, where clock is there. Clock is there. Now clock present in sequential logic, correct? And get is combinational logic. So here, no posit. Here what we need to write? The inputs. Here, or these are the inputs, correct? These are the inputs. A or B. How to know what is the data type? We have integers. Short count. Set the data type. No, see. Input is the direction. It is not data type. Input output is the direction of the variable. data type we are going to declare in test bench. In design, we don't declare the data types, we declare the direction. So declare the input and outputs means input here is not data type. This is the direction of the port A and B. We are going to make A and B as physical port, correct? A and B, they have physical significance. Now, how we can understand they have the physical significance? Whenever I am writing input A and B, the tool will understand that, okay, A and B direction is input towards the design. If I write output Y, means Y is the output direction from the design. Okay. Next one is, this is behavioral style. Okay, what I told you, I am going to just make a design to show you how to run a code in knowledge. If you don't understand, we are going to discuss this thing again. Okay. But for now, what I can tell, always is a procedural block used in Verilog for implementing design. Always at the right. Inside this A or B is nothing but the sensitivity list. We call this sensitivity list. Why sensitivity list? This always block is always sensitive with respect to A and B. Whenever A or B or both will change, this always block will execute. Means, suppose we are going to generate the value of A and B inside test bench, right? Then this value will come to design. From test bench, this value will come to design. Now suppose A value were generated 0, B value were generated 1. Okay. So that, please understand that how test bench and design both are connected and both are dependent with each other. Only generation is not sufficient. Only design is not. Only logic is not sufficient. We need both. So first, what will be done? As we are running the simulation using test bench, first the test bench will generate some inputs. Suppose the input is 0 and 1. Suppose it is not like that 0 and 1 will come. 1 0 may come, 1 1 may come, 0 0 may come. I am considering 0 and 1. A as 0, B as 1. That is been generated by the tool. So that generation will come here. That generation will come here. And it will check what is the value. A is 0, B is 1. Okay. Means A and B value were changed. I have some new value. That is A as 0, B as 1. Then whatever is been written inside this always block, those lines got executed. Are you getting my point? Inside that, what I can write? So in this case, can we say that always block is being used to program a combinational logic wherein the output is dependent on level triggering of here level triggering concept is not coming. Simple, you can tell that the output is dependent on the generation of A or B. Okay. It is also something similar to when we program latches wherein output is dependent on no. See, here there is no concept related with edge triggered or level triggered. Okay. Simple concept is inputs are coming, according to the inputs we are getting the output. There is no relation in between edge triggered and level triggered. Are you getting my point? That concept will come when we are going to implement some sequential logic. For sequential logic also, if you want the logic, if you want to implement the language, okay, then you have to write the logic. So according to the logic, it will work. Always block, this always block is only dependent on the inputs. He said that at the rate positive clock. Okay. If I write at the rate positive clock here instead of A or B, at the rate positive clock. Positive clock means what we know, sequential circuit always give you the output at the positive edge of the clock. If we want the output to be taken at negative edge of the clock, we simply write negative of clock. Understanding that one? But for combinational logic, there is no concept of clock. So simply combinational logic output is always dependent on input. For sequential, it is not like that. For sequential, it is not like that the output will be always dependent on the input. There are the concept of states. Okay. So we'll go there. In sequential, we'll go. But please understand for now the combination logic. Now, I have written A or B. Okay. Now, please understand. We are going to implement a 32 plus 1 multiplexer. We have to design a 32 plus 1 multiplexer. So for 32 plus 1 multiplexer, how many inputs will be there? 32 inputs. Correct. So that will cross your alphabet range also. You start from A, go to Z. How many alphabets are there? 26. So you need 6 more. So how you are going to write? A or B or C or D or E or F, like that? Should we write? Should we make our language redundant? What is the use case of language? Why we use language? Different language. Why the evolution of the language happening every day? To reduce the redundancy. Okay. To reduce the repetition. Repetition should not be there. This, instead of, if you write star, your work will be done. Now you use 100 inputs. 100 inputs. This star will fetch all the inputs. Star represents all the. So you need not to write all the inputs. Now what you need to remember here for behavioral modeling, you have to use a always block. For behavioral modeling, you have to use a always block. How you are going to write the always block, right? Like always at the rate star. This is something to be remembered. Next, inside what we can write? We can write the logic. See, I can directly write y equal to and this is one thing I can. This will work. There is no problem. Another thing I can write. If A equal to 0 and then B equal to 0. Okay. What I am writing, suppose you don't know the Boolean expression of AND gate. You don't know the circuit diagram of that AND gate. Only you know the truth table. That situation may come. That a person tells you that, see, forget Boolean expression, forget circuit diagram. You can't use. I am giving you the truth table. You please implement the AND gate. This is the way then you have to begin. I have written here simple English words I have written here. If A equal to 0 and B equal to 0. Now question comes, sir, y double equal to y double n. In here we are giving condition, correct? Condition. For condition we need to use logical operator. These are logical operator. Okay, logical equal operator, logical and operator. So whenever you are going to write any condition, in condition you have to use logical operator. Next, then y equal to 0. Right? You please see this 3 line and tell me, is there any difference that whatever we have written here and the English words, what I am explaining, is there any difference here? This is the first line of the truth table. This is the first line of the truth table. If a equal to 0 and b equal to 0. Begin, end. Means if this condition is true, my y output will be 0. Okay. Next, copy this 3 line. To copy this 3 line, what command I need to give? To copy this 3 line, what command I need to give? 3y. I want to paste this one for 3 times. I want to paste this one for 3 times. What command I need to give? What command? 3.
Yes, y and
y. I'm not getting this. First, I need to copy this 3 line, correct? So for that, what will be the command? 3y. 3y will copy this 3 line. Then my requirement is that I want to paste this 3 line for 3 times. The command will be 3p. First 3y, then come to this line and use 3p. Because after this line I want to paste. See here. What command I have used? What command I have used here? U. Whatever I have done, I just undo that. Okay. Come here. I want to paste this 3 line. I want to copy this 3 line. 8, 9, 10. So 3 y. 3 y means, can you see 3 lines? Yanked. Yanked means copied. Now I want to paste this particular 3 line for 3 times. Then I need to move my cursor here. Move my cursor here. Because I want to paste these 3 lines for 3 times after this line number 10. So whenever you have to paste this one, you need to keep your cursor on that line. Now if I give 3p, P for paste, P for paste. It got pasted after this line number 10. If I keep my cursor here and give 3p, then what will happen? It will paste those 3 lines for 3 times before this end line. Before this end line, you can see. This end has here. This end is not here. This end has come. So always come to that line, then else if b equal to 0, b equal to 1. I will be 0 or 1? 0. Else if 1, 0. Y will be same 0. Is the last condition correct? How many line is present inside truth table? That many logic we can write. 4 lines are there. 4 logics I need to write. The last one will be else. Okay. Now when we are going to write else, we need not to give the condition. Else do not take any condition. Else will do what? The condition is left out in the last, in the end. It will automatically take that. Y equal to? How this will happen, how this will get executed, I will explain. First, the execution will come to this line. Okay. Test bench value generation completed. Suppose test bench value generation completed. Then the execution will come to this line. Okay. It will understand the value of A and B. It will understand the value of A and B. Now, what example I told you? A0, B1. Right? A0, B1. This condition falls under which line? That one condition falls into which line? Line number 11, correct? A0, B1. Line number 11 means this condition is satisfied. So simply it will print y equal to 4. And again it will check if any new input set of input has come. Suppose 1 1 has come. A1, B1. So how the execution will happen? It will check this. No. Check this. No. Check this. No. Then if all these 3 conditions false, then automatically it will come to this one, else condition, and give you y as 1. Okay. Now this behavioral style is very simple. Whenever you only have truth table, you are going to use behavioral style. Now there are advantages as well as disadvantages of Verilog style, behavioral style. What is the advantage? Advantage is you have a control. You have a control over this entire logic. I can write 0 1 here. There will be no problem. It is not like that you have to start from 0 0. You can write 0 1. You can write 1 0. You can write 1 1 also. I can write 1 1 also. Else begin automatically it will take it as 0. So if I write 1 1 here, suppose I write. So I need to change here 1 1. I need to make just getting my point. So total control I have. Whenever according to the requirement I can make changes. But what is the disadvantage? See, this is for only two input AND gate. I need to write this many lines. This many lines. If I have 10 input AND gate, 10 input AND gate, I have to implement 10 input AND gate. Then what I need to do? 10 inputs means how many combinations will be there? 2 inputs, we have 4 combinations. 2 to the power 2. If there are 10 inputs, then how many combinations will be there? 2 to the power 10. 2 to the power 10 means, are you able to write this many like? No. So that is a disadvantage. Okay. Now, how we can resolve this? It is not like that we don't use behavioral style. Mostly we use behavioral style only. Mostly. But whenever the requirement will come, and if we see that we are not able to implement that one using behavioral style, then the data flow style will come to the picture. Simply I'll take the truth table, I'll use K-map, I will derive the Boolean expression from it. Okay, and I will implement this. So this one is behavioral style. Data flow style will be simple. The most simple thing is data flow. Assign by equal to and you can write y equal to a and b inside this other box. So, to implement the design, you need the truth table, okay, and to implement the design or implementing the design, if you want to make it easier, simply derive the Boolean expression and write it. The design will be done. Until and unless someone is telling that please implement using behavioral style, you can go with data for simple design. But for the complex one, the behavioral style of coding is needed. Actually, in practical case, whatever we are going to implement, that will be the mixture of behavioral as well as data. Okay. So, another thing is that whenever we are going to use behavioral style of coding, we need to declare the output as range. Output as behavioral What is the reason behind that? There are two reasons. See, in behavioral style, you can see one kind of behavior that until and unless the inputs are changing, the output is holding the value, right? Suppose at first 0, 0 has come. Okay. We got y equal to 0. Now, until and unless the input gets changed, the output also will not change. Till then, the output is holding the value. Now, in VLSI, it is not like in Verilog. In VLSI, whatever variable holds the value, that should be registered. Now you can tell this reg is what? This reg is data type present in Verilog. Now, if I tell you some circuit that is open or continuous, what will be the data type for them? Any idea? My question is that some variable that is open or continuous. Reg is discrete type, correct? Sometimes it will hold, sometimes it will release, hold, release. That way it will go. But I am telling you continuous and open. If sometimes open or it is continuous, take it as continuous. What data type we can use?
Wire.
Where? One second, just give me 1 second.
Hello, sir. Your voice is not audible. Hello.
Yeah, sorry.
I think you are muted.
Sorry. Now, is it audible?
Yeah. It's audible.
Okay. So for test bench,
Can you please
what I was
explain?
telling, what I was
Okay.
telling,
Yeah.
for test bench, it is good to give the test bench name like this, like TV underscore and. So you'll find that this is my test bench for Android. Otherwise, if you see in the same folder, if you are going to implement and get or get exorbit and get or get exorbit, now you have three design and or exorbit. If you are giving all the test bench file name as TV, then what do you need to do? Every time you have to open all the TV file and see whether this is my and get test bench or object test bench. Okay. So by giving this name will tell you this is the object. Next one is first. First in test bench you have to include the design file. How you are going to include the design file? Tick. Which tick? First this tick. Tick. This tick is what? Which one? Not single quotation. This tick you can find below your escape button. Below your escape button you can find this tick. Tick or negation. Both are in the same button. So that tick you need to use. Do not use single quotation. You can see the color is changing. This is correct. This is not correct. This tick will do. Then give a space. Then inside double quotation, give the design file name. I am telling you design file name. Again, what is the design file name I have? And underscore get.v with extension unit. Okay. Next one is module. In the module, I will give PV. PV is my test bench module. You can keep this one as uniform. Every test bench module name you keep as T. There will be no problem. Next, no port list should be given for test bench because test bench do not have actual ports. Test bench is going to connect with the design and verify the design. So, no port list. Then, declare the inputs as red, output as whatever input is there in design file, blindly come to test bench, write the edge, write the variable, input variable. Whatever output variable present in the design, come to test bench, write where, output. Simple. Okay. There is nothing to understand. This thing you need to remember. These are the steps you are going to do for the next 1 month. Okay. At least for next 1 week. For the next 1 week, we will do this kind of thing, so that you will become very much thorough with all the steps.
Sir,
Yes, please tell me.
what is wire, sir? It will generate the output. Command.
Where means
Why?
where? Yeah, I'll tell you. Yeah, definitely.
Why
Why
should
wire?
we use wire?
Yes, I will tell you. Come here. And get correct. And get. Right. This is my A. This is my B. This is my Y. Okay.
Mummy.
What I told you, where is what? Continuous, correct? Which is continuous. Edge is what? Which is discrete. Which is discrete. Now you understand. With respect to test bench, suppose A has come as 0, B has come as 1. Okay. Immediately we'll get Y as 0. Correct? Again, when it will change, suppose from 1 to 0, immediately we'll get Y as 0. Suppose next one come as 0, 0. Immediately we'll get Y as 0. So see, whenever the inputs are coming, immediately the Y gets updated to the value. So this is a continuous process, correct? I can tell Y this A port got ended here. This B port got ended here. Yes or no? Can you see Y port got ended anywhere? I just ended here. But if you imagine, Y is going on. If we consider only one particular gate, means Y is continuous. Y characteristics are continuous. It is not discrete. That's why we declare Y as where. Any output, you can see for any output, they are always continuously driven. Whenever inputs are coming, we are getting the outputs. Inputs are coming, we are getting the output. So simple. Y as well. Y A and B as red. By seeing this one only you can tell. They got ended. They are not continuous. Every time they are holding the value until and unless a new set of value is coming. So in test bench, we need to declare A and B as where not. Simple statement is in test bench where design inputs. Design that's H. Here as okay. This is something statement that you have to remember. Why I have explained, but why is not so much important here. Why is not so much important here? This is, you can say that this is language provided rule, a literal, that inputs should be declared as red, output should be declared as well. Okay. Now, if someone tells her why you are doing the job, now asking why is not important. Important is what we need to do. We need to do the job. Yes or no? Why you are doing this training? To get a job. If someone asks why you are doing this training, that is not important. What you have to do to complete this training, that is important. For that, what you need to do? You need to come to institute, attend the session, understand the concepts. So this is nothing but the concept. That this is there and it is mandatory. Some exceptions are there. Also, those exceptions depend on the requirement. But mostly, means hardly you will see that kind of exceptions. That we are declaring some output as red. Okay. Next, declaration is done. These three lines.
Sir,
Yes, Mr. Lee.
sir, but in the design, that output was given as reg like Y, but in the test bench we are making it as wire. So, what is the difference
I'll tell you.
between
Why in design it has been declared as reg. This reg we need to declare for exclusively for behavioral style, not for data flow and get level, exclusively for behavioral style, because in behavioral style we are implementing this logic. This logic tells until and unless the input, the set of inputs are changing, or you can tell until and unless this sensitivity list is changing, the output is holding the data. Output is holding the previous data. Yes or no? If you simple, just forget this and get. Just forget this and get. We are going to implement a simple addition logic. Simple addition logic. Okay. First, 0, 0 has come. Suppose 0, 0 has come. Input 0, input 0. Output is 0. Okay. If every time 0, 0 will come, output will be 0 only. Na? When it will become 1? When either 0, 1 will come, or 1, 0 will come, or 1, 1 will come. Yes or no? Simple addition logic. Or simple addition logic I am telling. 0, 0. For 0, 0 has come. Then suppose for next 10 times 0, 0 is coming on. So why is not becoming 1? Why is not changing? Why is holding the data? At what point y will change the data? When any of the bit will come as 1. Correct. So for that entire time y is holding the previous data. Correct. Y is holding the previous data. So what I told you, any variable, if any variable has this holding kind of nature, we are going to declare them as range. Here this y has holding kind of nature. That's why we declare as range. For data flow y we don't use range. For data flow why we don't use it? By seeing this line you can tell. Whenever a and b will come, y got updated immediately. Whenever a and b will come, y gets updated immediately. So there is no holding kind of nature. There is no holding kind of nature in data flow. You can tell, sir, you are implementing same AND gate. So why this kind of difference? This is language provided difference. Because whenever you are writing some line, tool will not understand this English word. Tool will understand what? Whatever is being converted. Which tool can read. Okay. So tool can read what? Tool can read the inputs. Whatever inputs are coming. Okay. So tool gets the output, inputs. And if tool understand, okay, this is the behavioral style which is being implemented, then automatically it will try to find whether the output is being declared as range or not. If not, error. But for data flow, if you give range, error. Because in data flow, the behavior is or characteristics is not to hold the data for output.
Sir, but when we will in the test bench, let's say when we will give combination like 0, 0, 0, 1, 1, 0. So for the data flow model also, let's say when the first input is 0, 0, so y will be 0 until the input is changing. So y will be 0 in the waveform. So that ways the data flow will also like be holding the value 0 until we get the second combination.
No. For data flow, you are writing this Boolean expression, correct? You are not writing any logic. Are you writing any logic? That if this is happening, we'll get this. If this is no, directly Boolean expression you are. So how it will happen? A and B will come immediately while you will get the value. Then A and B will come immediately while you get the value. So there is no holding kind of nature. This is the Boolean expression. For any Boolean expression, you will not find that the output is holding the data. The inputs are holding the data there. Now for test bench, if you come to test bench, you can ask, say here you have declared the range, y as range. Here y where? This is the rule for test bench. inputs should be declared as well. So you understand the rule. You understand the rule. There are some rules that is been present inside the language. So you have to understand the rule. First rule is, when using behavioral logic, declare the outputs as reg type. Okay. Then there is another concept. That concept is always is a procedural block, correct? That is what I am telling. This is rule for language. Always is a procedural block. Inside procedural block, whatever variable is being used at the LHS side of the stack, that should be declared as reg. I will write this one.
And sir, is it also possible like something which is not the output can also be declared as reg, like some kind of intermediate signal when we have like a
Yes, yes.
big circuit? Okay.
Yes, intermediate signals we generally use as where, but if the requirement will come, we can declare them as reg. That always depends on the requirement.
So sir, like suppose when we define something which is not output, but it is defined as reg. So when the design will be synthesized, so those reg data type variables will be synthesized in the design, or how it will?
In design, you will not find any variable that is been declared without declaring them as input or output. If any intermediate signals are there, is needed, then that will be declared as reg. So intermediate signals, those are not synthesized. Those are intermediate signals.
Mhm.
So if it is not synthesized, we need not to declare them as input and output. Are you getting my point?
Yes, sir. So, but because generally, like in the designs of suppose sequential circuits, there generally like we see that we don't directly assign the value to the output. We use some kind of like reg signals, and then after the always block, we assign that variable value to the output value. That kind of logic is sometimes.
Yeah,
So,
you
why
will
cannot
find
we?
that one. Suppose if we are going to implement a Jacob flip-flop, suppose we are going to implement a Jacob flip-flop. Okay. A JK flip-flop has one state, that is called memory state, right? So memory state, if I write output equal to output, Q equal to Q, that doesn't mean anything. So there what we are going to use? We are going to use a temporary variable. That temporary variable we are going to declare as reg type. Reg temporary variable. That we are not going to declare as input or output.
So, but there also we could have like used these if else statement. Like let's say we are defining some D flip flop, and if we just assign the value of the let's say 00 input and the characteristics tables of D flip flop, assign it to the output directly. Like what will be the harm in that case? Like why we need an extra temporary variable there?
No, you are not getting my point. Extra, you only ask that if we need any extra temporary variable, then how we are going to declare. That's why I have given the answer.
Oh,
Okay. If you are asking the question that if we have any extra variable that is not the input and output, so how we are going to declare them? We can declare them as reg or where. How that variable is being used, according to that we need to declare them.
okay, sir. Got it.
Next one is the first rule. Okay. In procedural block, in procedural block, how many procedural block we have in Verilog? There are two procedural blocks. One is initial Another one is always. Okay. Here we have used always. Now the question comes, sir, in design do we use initial? No. In design we use always block. Because always block are synthesizable. What do you mean by synthesizable, non-synthesizable? Synthesizable is what we can convert them to gate level. We can convert them to gate level. Non-synthesizable means need not to be converted. In design file, whatever we write, every construct, every keyword should be synthesized. Okay. Now, in procedural block, initial and always. Whatever variables used at LHS cell blindly declare them as rich. This is applied for design as well as testing. Do you understand this statement? Inside procedural block, whatever variable that is being used at LHS side of the statement. What is the variable that is being used at the LHS side of the statement? Can you see? If you see this entire always block, what is the variable or what are the variables that is being used at the LHS side of the statement? Is it AB? No, only Y. This is statement. Don't mix with this. This one is condition, logic. This is inside the logic. Okay. You can see this is not statement, as I didn't end that one. I didn't use any semicolon. Means that is not ended. I used semicolon here. Means this is one statement. This is one statement. This one statement. This one statement. You can see everywhere Y is being used at the LHS side of the statement. So declare Y as rich. That is another one. That is the rule or concept. What I explained previous, that is the concept. Whatever I have written now, that is the rule. Next one. Next one. In behavioral style. Behavior style. Clear? Yeah. Outputs as such. In design, you have to mention this in design. Okay. In test bench, inputs will be rich. Outputs will be. These are the three rules you have to remember always. Because these three rules, there are no exception. There will be no exception for this one. So we were in test bench. So which one? Point number 2. In behaviorals, okay, style. This one you are telling. In behavioral style of coding, declare the outputs as rich in design. Right? This is declare the output as rich. So next one is test bench. Declaration is done. Next step will be instantiation. This step